In this video, we're going to look at the ball mill. We'll look at all of the main parts that make up a ball mill. We'll look at exactly how it works. We'll look at when you're likely to see ball mills and in which industries. And then we'll have a look at some of the interesting design and operational considerations associated with a ball mill. And these studs allow us to mount what they refer to as armour within the ball mill itself. Now the armour is represented by these plates. There's one here. They look slightly square in shape. And one over here, one over there. Just see if I can spin around to get a better look. So here is one complete row of armour. And you can see that there are no connections between the stud itself and the armour, at least not on this side. The armour itself is made of an abrasive resistant material, and this is often manganese alloy steel. Now if this ball mill was being used for ore, for example, or hard rock, then normally the ore will be crushed before it enters the ball mill, and then it will be fed into the ball mill either wet or dry. Dry means that we use very little water or moisture, and wet means that we add water and form a slurry, and that slurry is going to occupy about 50% of the ball mill's entire volume. Now, the bearings may be cylindrical roller bearings for smaller ball mills, but when you get to using larger ball mills, you won't be able to use cylindrical roller bearings anymore, and you'll actually use what they refer to as trunnion bearings. These are hydrostatic bearings. That means that you'll have an oil pump supplying the oil to the bearings, and the oil will form a boundary between the bearing itself and the ball mill shaft. Grinding is a low efficiency and power intensive process. For this reason, the grinding stage of a mineral processing plant may account for up to 40% of the plant's total operating costs.